Welcome to this video, which uses a very simplistic set of examples to explain the concept of margin of error in your textbook. I'm looking at a USAToday snapshot, a graph chart, if you please, from the previous year, and I'll try to scoot this on the screen so it all shows up at once. And it says, what is the longest that college students can go without using digital technology? What's the longest anybody can do these days? Some people feel like they seemingly can't live without it at all. They're constantly at it as if it were a 207th bone of their body. You'll notice the results of this. 50% of the people said they can go up to 30 minutes. 17% of the people surveyed said 31 to 60 minutes, and 33% said over an hour. I guess those were the choices because those three pie slices add up to 100%. What I want you to notice here more so is the number of students that were surveyed. This was a number of students, 500 students were surveyed. You probably have seen this concept of margin of error in the news before. Basically, to make this simplistic, the more people that are surveyed and trying to get more people that are sampled and trying to get a survey and get this statistical data, if you've chosen the sample very carefully and it doesn't have the bias that's possible in a survey, the more likely the accuracy of the results. So if I survey 500 students, I'll get a good result when compared to surveying, say, 4 students. I can rely on the data. If I surveyed 5,000 students, maybe an even better situation will happen, again, if my sampling is correct. You use a very simple formula to use the margin of error. It's 1 divided by the square root of n simply referring to the number of people that are involved in the survey. So the n in this case is going to be the number of college students. So to get the margin of error data, we simply put the number, in this example, we simply put the number 500 in there. Now I've shown individual students how to do this on a calculator because some of my students are very nervous about it. So when you do this calculation, I won't go through the calculation process on this video because it varies according to whether you're using your computer, your calculator, a phone app, or what have you. So there are some variations sometimes in the order in which you put all this information. So I'm going to use my own computer right here and get the results, and I'll give those to you in just a second. So what this will give me when I write this out, when I do the calculation, I'll get roughly 0.04, which of course if I convert that to a percent is 4%. So the margin of error for this survey is going to be equal to 4%. Now if I want to look at the range of the values as far as what I can be confident to be true with this, what I do is I take any one of these percentages, and I'll use the one that says 50% right here. In fact, I'll select a different color to emphasize this. I'll take the 50%, and to get the confidence range here, what I will do is I will take that 50% that is in my survey. I just picked one of these percentages at random, and it's okay with any one you choose. I'll take the 4% margin of error that I had in this calculation. In the first situation, I'm going to subtract the 2 percentages, and in the second situation, I'm going to add them. So my confidence interval will be anywhere from 46% when I subtract to 54%. So it's that straightforward as far as how you do the calculations. I'll now use an example that's modified slightly from the book, and I think I'm okay doing this. A survey of 2,818 Americans, and that's not the year 2818. The reason this may sound stupid to say with a larger YouTube audience is I know my students who may misunderstand, and I'm not saying they're lacking intelligence, but I'm saying they may misunderstand because of their math phobia. So again, don't take this personally. There are 2,818 Americans in this survey conducted in 14 U.S. cities, indicating that 73% of Americans know that health experts recommend drinking 8 or more 8-ounce servings of water each day. Now, there are students who feel because of their math nervousness that they've got to use every single number that is in this problem, and you don't. We're simply looking at how many people took the survey and what the percentage was. So to calculate the margin of error for this one, you simply take that really small formula I've mentioned already, 1 divided by the square root of n, and referring in this case to the number of people in the survey. So that's going to be 1 divided by the square root of 2,818. That's not an exact value, but if you throw this guy into the calculator, and I'm doing that right now, you're not seeing this because I'm doing this on another computer, I get decimal 0.18. Now if I do that as percentage, I could write that as either 1.8%. If you wanted to write that and round it to 2%, that's perfectly fine with me. That's the margin of error that we would use here. Now to get the confidence interval, and my stuff may split apart right here, so you'll have to bear with me. The confidence interval, what I will do is I will take the 73% that was in the survey, and I'm going to make this easy just for the video, and I'm just going to use the 2% that I got earlier. And I'm going to scoot this out of the way so that my numbers don't overlap and cause some possible confusion. I'm going to subtract them, and I'm going to add them. So my confidence interval is anywhere from 71% to 75%. Again, I got these numbers by adding the 2% to the 73 and by subtracting it. And that's the way you do these exercises. Again, if you have questions, you know that you can always contact me or get help from an individual student.